starting object-oriented programming. See some love in chat. Okay, first things first, I am going to go and say the usual. We are being recorded as usual there, so keep that in mind. Anyway, second note here, just a little housekeeping note. We decided to kick up a new Discord channel, the Monday Generals question. If you guys have technical questions like help by Pygames not running, go ask over there. On Zoom, we'll try to keep the chat relevant towards the material that's being currently taught. I'm not going to try debugging your stuff live. We probably are running a little bit too short on time. We got plenty of vendors who can help with that anyway. Anyway, let's jump right into it. So object-oriented programming is made of two fundamental things, classes and objects, and we're going to be hitting those today. And we're also going to get the foundation of our game started. I'm excited. All right, let's take a look at what objects are. Actually, before I do that, let's go talk about why we need objects, because technically speaking, you could do all your programming without objects at all, but I don't recommend it because classes and objects make things really, really scalable. It makes it organized, simple, modular. Those are some nice buzzwords with examples. So let's go and just take a look here. I'm going to say I want to go and build a program that has inventory on my pets. I am running a pet shop. And so I might go with a snake1 name, and I say Sam. And I'm going to say snake1 age is, I don't know, 3. Snake1 color is going to be green, right? And that's fine and dandy and all. I got my snake here. And if I want to get a second snake, that's not the end of the world. I'm just going to have to go copy paste this entire block. And I'm going to go and start typing some stuff into here. And I can go and change up my name. Snake2's name is going to be Sandy. Snake2's age is going to be 5. Snake2's color is going to be lime. But it works, it's functional, but it's not terribly practical. I can't really figuring a way how to go and talk about just snake1 in general. I mean, if I want to talk about snake1, I have to talk about snake1 name, age, and color every single time. There's no just concept for the snake itself. And now if I want to start talking about the pet store itself, or if I want to expand to the city itself, I have to go and list every single little variable inside. It's not going to scale very nicely. I don't think that it's going to fly very well. So instead, I'd much rather go and take a look at objects. So what are objects? I'm going to go and pull back with what are variables. And I used an analogy last week. Variables are boxes. Boxes that have a little label at the front, that's your variable name, and then boxes that can go and carry stuff. So maybe Richard's shoes is my label, and inside I'm going to go and put in my shoes. Or maybe I have X as my label, and inside I'm going to put the number 3 in there. Really, variables allow you to carry anything. Objects are just variables. So objects are really big boxes, and inside those boxes, you can have more variables inside. So you just simply have one big box with little boxes inside. So if we go and say we got a snake box, and you put the label snake1 on the front, and you're going to go put a little box inside that's labeled its name, another box that's labeled its age, a third box that is labeled its color. So really, it's just a compact way. You just have a big variable called snake1 at this point. So we actually saw objects before in the past, and it's actually not much of a surprise that pygame.rect is in an object, and Pygame just tends to use objects in general. It makes life so much easier once you go and understand them. We can go and group together multiple properties. I mentioned the snake example. I can mention as well the Pygame.rect example. So we can go and list off the properties here. There's the X coordinate, there's a Y coordinate, there's a width, there's a height. You could go and put them all together. And I do want to also highlight, if we take a look at these slides here, that each one of them just have different properties. I mean, yeah, they both have X, but the X of one rectangle is unrelated to the X of a second rectangle. I draw my first rectangle right here. I draw my second rectangle right here. They both have X numbers. They're just in different spots. This should really be natural of an idea to see here that this 50 is unrelated to this 200. All right, let's go and take a quick look at the syntax of this thing here. So as usual, I'm just going to go pop open my code editor here, and I'm going to go and bring us across here. Let me go navigate over. I'm going to go into my Ignite sessions folder, the one that we've already have. And I'm going to have main copy and rename. I'm going to use this a lot today, but just keep that on standby. And I'm going to go make a folder named session2. Got a lot of files inside here already, but you can just follow along and go create those. If you have VS Code installed, you go and open open with code, and you'll be taking a look at a screen just like mine. Let's go and take this main copy and rename. I just have it sitting around on standby just for the exact purpose of doing this. And I'm just going to go main lots of Rex, right? And what I can do down here, I'm going to go down all the way to my setup section. I can go and start typing in rect1 equals pygame dot capital R in rect, open bracket. And now it's actually just a function. I'm going to go and plug in a couple numbers here. So my x coordinate, I don't know, maybe I'll go 200. My y coordinate, I'm going to go 300. My width, I'm going to say, I don't know, 50. My height, I'm going to say 60. And with rect1 here, I can go and manipulate all the values inside it. I can manipulate the properties. So with the dot operator, I'm saying take my big box, look inside, grab one of those smaller boxes here. And now I can go and talk about the X box inside here. Good game console here, but anyway, we can go and say, maybe I want to change it. I want to go 250 or rect1 dot y. Maybe I want to change the y value to be 305. I don't know. I'm just punching in a couple random numbers here. Rect1 dot width, I can go and change that to 56. Rect1 dot height is equal to 67, something like that. In the meanwhile, I can also just make rect2 equals pygame dot capital R rect, and I'll just punch in some random numbers here, 1, 10, 20, 30, 40, and I can, of course, just like rect1, change that around as well. Rect2 dot x, I can change that to be 100. Rect2 dot y, I can set that to 200. Rect2 dot width, I can set that to 300. Rect2 dot height, I can set that to 400. And intuitively speaking, these are all just going to be different values. So down here in my draw section, I can go and pump those out. Pygame.draw.rect, that's the drawing function to go and draw on the screen here. We're going to say where? On our screen, please. What color? I'm going to open bracket, close bracket. Someone give me a color recommendation in chat, please. Let's see, yellow, purple, red. I am going to go for, you know what? Yellow is a pretty decent one. Oh, blues, we're getting lots of blues. Sure, I'll go for blue. RGB, 0 red, 0 green. I'm going to go for full blue, maybe pump it up just a little bit, make it look a little pretty. And then afterwards, I'm going to go and just simply insert rect1. I should draw it there. I'm going to copy this, and we see some people asking for yellow. Okay, I'm going to take my second rectangle, and I'll make that yellow. So that's R255, G255, B is 0. Transparent's a little difficult to see, so we're not going to go do that. Someone asked, is this the constructor for rect? Yes. We're going to see what constructor means later. Let's not worry about that right now. I can go, of course, and run this, and we should see 2 independent rectangles. Whoops. I think that one's covering up the other. That's a little bit hard to see. I could probably just flip them around to go and prove that. Whoopsie. Naturally going to have a problem here if you have one rectangle that's significantly larger than another. There we go. Rect1 is going to be this little blue one down here. Rect2 is going to be this big yellow one above it. Okay. So hopefully that idea is just captured intuitively. It's just a big box that can carry a lot of little boxes with it, right? And so I'm going to go and pop you guys into a quick question here. This one should be super easy. Let's go and give you 1 minute to go and figure out the answer to this. Oh, wow. That's interesting. I think we are looking at the wrong quick question. Yeah, I'm sorry about that, guys. I think that we have not settled that up quickly. Shall we try that again real quick? Is there a chance we can just go and pop out the options here? I can go and provide the questions real quick. And we will try that one more time. Apologies for that, everyone. That is not what we expected to do. Let me just go and open up the document real quick. I'm just doing that off screen where you guys aren't able to take a look. There we go. Now we're getting the proper quick question. Let's try that one more time. Sorry, guys. Okie dokie. I see a lot of people already flooding in the answers here. 30 out of 36 of us. I think we're doing pretty darn splendidly here. Gonna give it last 10 more seconds here. You all are doing super fantastic on this one. Okay, perfect stuff here. So I think that everybody was able to go and tell this. This was a super obvious one here. The result is going to definitely be 15. Why? Because rectangle 2 is not related to rectangle 1. We were trying to throw you off, put some quick trick questions in here with this width variable here, is rect1 dot width, but you guys saw right through it. The only line you care about is rect2 dot width equals 15. And when you print it out, that number is going to be 15. Fantastic, guys. So good. In fact, I think I'm going to throw you guys into the first exercise of the day. But before we do, we got a couple of things to go and install. I've decided to go and pre-build a bit of code for you guys, make your life a little bit easier. Everybody go and click on this tree.py file here. When you do, it will look like this. I'm going to go send this chat down into chat. You guys can all just follow along there. Please click on this link here. Please join me. And when you're in here, it's going to be the exact same as that main copy and rename file. We're going to right click. We're going to go save as, and it will give you a nice little prompt on where to put it. Hey, what do you know? I think I already have it right in the spot I want it. Okay, everyone, please put in tree.py into their files there. And on top of that, when you guys are done that, okay, I can just use this lots of rect one more time, and I will just knock these rectangles out of existence. Everybody, once you guys got that, how many of you guys got that file downloaded? Give me a thumbs up if you got that downloaded. Good, 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 good. Yes, looking good. Excellent. Everyone copy along with me. We're going to type in one line of code. We'll see what it means later. From tree, lowercase, imports, tree, uppercase. Pay attention. From lowercase tree, imports, uppercase tree. Please, everybody type that in with me right now. When you guys are done that, you guys now have an object called tree ready for your use. So I could go my tree equals uppercase tree, and it will just be open bracket, close bracket. There's some properties inside my tree that we can access, like my tree dot trunk X, my tree dot trunk Y, my tree, etc. But that is going to be directly on the slides. So without further ado, I think I'll go and turn it over to you. You guys can go and take a look at all the properties here. Or if you're feeling adventurous, go take a look at the file tree.py itself, and you can find a list right in there. Let's take 10 minutes to go and do that. All right, 3, 2, 1, go.
I think some of you aren't assigned to rooms again, so just type in the chat which room you're supposed to be in.
I'm still muted. Huh. All right, there we go. I'm finally getting people in now. Excellent. How is everyone doing? How far have you guys gotten? Does anyone want to share the answer that they got with it? Oops. Couldn't get the tree. So how many people were able to go and draw the trunk of their trees on the screen? Nice. We got some people who drew all of it. We got some, I saw some people who got some trunks. I got some green leaves. Oh, I love it. Excellent. I mean, like with this miserable winter out there, they promised to be warm today, but it's not. I'm a little disappointed in that. All right. If you guys got the leaves, but they were kind of a little bit off, don't worry about it. It's not the end of the world. That being said, though, let's quickly walk through the solution of it together. So I went and started with from tree, import tree. And then from there, I decided to go and just block out my code, get started. I decided I want to draw multiple trees. So I'm going to go and get a list. If you guys just drew one tree at a time, that's a-okay, but I can have a list of variables. So why can't I have a list of tree objects? I got brown as color just defined as a default here, and I got some defaults. I got a trunk width and a trunk height. And I decided to go make a little helper function. You guys notice how difficult it is to get those trees aligned, but I decided to go and make my life a little bit easier. So what did I do? I put in my X value, my Y value, I got the size of my leaves, which is a nice little square, and I got my color. First things first, I created my tree variable. Tree variable is equal to this tree function call here. And then I decided to start messing around with the X value. Tree.trunkX is equal to an X value, with a little offset here, this trunk width divided by 2. Y value, I've just plugged it in straightforward. The leaves here, I said X minus the size out of 2. Again, just a little offset there. These are little math tricks. I don't expect you guys to be masters of mathematics. I'm here to go and talk to you guys about objects. Tree leaves Y is Y minus size. Tree leaves size is going to be set to the size and color. Beauty of functions here. You can go and pass in parameters rather than trying to juggle this math inside your head. When I'm done, I'm going to go and say, take my list of trees and plug in this tree entry into there. I'm plugging in my entire box into a list of really big tree boxes. Down here, you guys can see my little function called, my little helper convenient function. So I said at the X coordinate 200, at the Y coordinate 400. I'm going to set the size to be 70 wide, and I'm going to get the color here, which is RGB. So that's going to be pretty darn green. I've got some other colors here. I think this one is orange as well. I'm going to go and say, let's ignore this tree here, mostly because that one's going to be confusing if you guys aren't watching that. So afterwards, down here, I got this set up for a little bonus feature here. So let's go and take a look at this code. This is a basic tree, how you go and draw it. I'm going to say pygame.draw.rectangle on the screen, take my brown color, which is that color all the way up here, 1561142. And I'm going to go and say, open up a tuple, and I'm going to go and dump in the values here. Tree.trunkX, tree.trunky. I'll put in the trunk width and trunk height. Those are just some quick defaults. That's going to put my trunk on the screen. Now I need to go put the leaves on top. That's just another rectangle. Pygame.draw.rect. Again, let's repeat the process here. We'll put in the screen. This time, we're going to go and put in the color of the tree itself. We open up another tuple here, and we're going to go and say the leaves are going to be drawn here. So where's the leaves X, leaves Y, leaves size, and leaves size, which is just basically going to be a little bit larger and a little bit larger. Pop that open, and we got the 3 lovely trees. I got a list of trees, so that pops up 3. If you guys are just working on your first tree, a-okay, it does not matter if you got 1 tree or 3 trees. For those of you who did have a little bit of time to go and explore the bonus, I challenged you guys, can you guys make a list of leaves to add onto every single tree? You can put any variable inside this tree structure here. And I decided down here, I'm going to say, put a list of tuples. And my list of tuples, well, I just use that as a bit of a dummy. And so over here, I'm going to go and take all this code. I'll bring it back to life real quick. We go and set up another tree, and I'm just going to manually plug in some coordinates for it. And then afterwards, all my branches, I'm going to go and just put in a tuple. I define the structure. So this is the X, that's the Y, that's the size. X, Y, size, X, Y, size, X, Y, size. And I'm just going to turn on one little Boolean here, just for my convenience. So down here, if you did have the fancy trees, you would go and draw your rectangles, but for the leaves, you would go and do it a little bit differently. You'd have to go through, iterate through a list inside tree.branches for leaves in tree.branches. Branches being a list that lives inside trees. You can have lists everywhere. And then you just go and draw it out. You say leaves X coordinate, leaves Y coordinate, leaves width, which is a size, leaves width and height, which is a size. And with that, you can go and get a nice little pretty tree with extra leaves on the back. If you guys want, you guys can hang on to this code. It might be something pretty for you guys to put in your games in the future. No pressure on that though. Anyway, let's move on. That is objects. Any question about objects in general? Okay, I think that no questions sounds good. Of course, go ask your mentor if you do have questions. Give the last 5 seconds for someone to finish typing. Okay, let's jump on to part 2, classes. Classes and objects, bread and butter, they go together so splendidly. All right, so first things first, what is a class? A class is a way how to go and create objects. Yeah, we are in a class. We're a class that's making a template of structures, but back into the world of the programming language here. You guys just saw what objects are. Objects are individual little pieces. So down here, I got the individual little snakes. They're physical things. You can have lots of objects of the same type. All of them are snakes. What is that type? That type is the class. It's a blueprint. It tells you a template on how to make these things. You see this object down here? You can read this really small text that's name equals buttercup, or name equals venom, or name equals chai. Or you can just have a class snake which says, hey, there is a name. I'm not going to tell you. There is a color. There is a species. And it's going to be defined as this nice little squiggly drawing here. And you get to go and fill it in yourself. It is the template for how to go and create things. Let's take a look at the anatomy of it. This is a bit of the syntax of it. So we're going to take a look at dogs, for example, here. We're going to say class dog, capitalized letter D. Let's pay attention to that little D in detail, colon, and then everything inside gets shifted over by one tab. We're going to go and have this line called def underscore underscore init underscore underscore self. Don't worry too much about that. We're going to talk about that a lot more in detail here. But hey, here's some things that might look familiar. Member variables, self.name. You know, we got a dog with a name. We got self.sound, that goes woof. And just because this thing here is kind of looking similar to a function, I'll give you a spoiler effect. It is actually a function. You can go and put whatever code you want inside. So somebody chose Rufus Woof. If you guys take a look at the tree example that we gave you, we take a look, and that's trunk X is 0, trunk Y is 0. I set up all these numbers here. So I technically put in some code, but I just set every number to 0. But nothing really stopped me from making it like 100, for example, as a default. So in here, we see the default, Rufus Woof. That being said, you guys might be a bit confused. What is this done underscore init underscore function thing? Well, this is what we call a constructor. Init is short for initialize, or to go and create, basically. It's a constructor that takes this blueprint and transforms it into a thing. So my thing, or my object in this case, is a truck. And I want to say, I want to go and get an assembly line. How do I go and build trucks? I need to tell the engineers, hey, here's what a truck should look like. You should have these dimensions and have this many wheels. That's my class. It tells you all the properties on how it should look in general. You go to the initializer, which is basically the factory line. It's a function that when you call it, it goes and zips, zap, bolts it all together and builds you, boom, a truck. That's your object. And finally, once you got the object, you know how it goes. You can customize it wherever you want. That doesn't have to be delivery. That could be, I don't know, refrigeration for something. I got to think of more creative examples. Anyway, let's walk through it a little bit more slowly, step by step. So well, I kind of lied about the fact that there is this tree that takes no parameters at all here. I said it only just takes this one weird word, self. You can honestly put in any number of things you want. It is a function after all, so you can pass in whatever you want. So we're going to go and conventionally say that what we want to pass in are going to be the properties. We saw an excellent example of this way back when we were talking about our rectangles. And oh, thank goodness, I'm here, so we can talk about it real quick. And we can see pygame.rect is a function call. And if we just start plugging in some numbers here, that's the X number, that's the Y, that's the width, that's the height. Or according to this example here, we can go and say, like, I don't know, I think this might be a student. That might be the example we're working with. So you'd see class student, and we say object name, object ID. And you say Bob as an input, or 123 as the object ID, and you can plug those in. We'll work through an example together. Last thing to note, this self keyword always comes front. If you're scratching your head, let's go figure out what that self keyword is. So self is honestly a little bit more of a tricky concept to wrap your head around. And unfortunately with Python, you have to get thrown into it right away if you want to use classes and objects. But I think that a good way of thinking about it is that self refers to the box itself. When we're talking about building that box, we need a way to talk about the box itself. And we're going to see self.name, self.age, self.gender. Really, a good analogy to go and take a look at this is that self is a lot like the word my in English. So I have me, I'm a person, okay? And I want to set up my name. My name is Richard. Self.name is equal to, well, Richard, whatever you want to plug in there. My age is 22. You go and plug in that number over there. My gender is male. You go and plug this in. The self, which is the person itself, the one that we are talking about, that we're in the middle of creating right now, is this self here. And you set this one's name, this one's age, this one's gender, my name, my age, my gender. When you go and finally construct this outside of the code, taking a look outside of this tree class or outside of rectangle and back inside this main class over here, when we take a look from the external world, we go back to calling it by its object name instead. Because when we're talking about somebody else here, you can start talking about things like Richard. So inside, if we have a classroom, and if I'm not the only person anymore, we can go have Richard, we can have Anmol, we can go and have Sean, we can have a lot of different people in this room. We no longer are talking about just Richard's himself. I'm not that selfish. So we say we create Richard and we want to talk about Richard's age. We go Richard.age. We're no longer in the my world. And I did see a quick question. Do you have to use the word self or can you use anything else? Technically, you can use anything else, but a lot more people would prefer to use self. It is typically the preferred way. And goodness gracious, if you want to set Richard's age to 80, you young whippersnappers, which one of you have turned me 80? Let me know. All right. Some other things that we should be taking a look at, some things that we are quite familiar with. We got class person here, and we got definite, and we can see that the member variables, aka what defines a person, what is that template that we want to use? That's going to be all on this left side. That's the self.name, self.age, self.gender. And as we see, we are going to go pass in some parameters, this orange color here. I realize I chose that to be a bad color. It's a little hard to read, but that color typically is going to, or that, not color, that variable is going to typically match. It's a pretty common pattern here. So if I want to go and set my name, I'm going to just put in the same name parameter. Age is age, gender is gender. But keep in mind, self.name is not the same thing as name. If we remember that example way back on the first quick question, when I said width versus rect.width, different variables. Same case here, these are different variables. Please keep that in mind. All right, let's go work together on this. I'm going to go and work through the slides. So everyone has been following along. Everyone's got to see my lovely tree example here, but let's go and complete my pet store a little bit. Let's make it a bit better. Off in VS Code, we're going to go and press the new file button. Click that. Let's go and name this link snake.py. Recommend you keep it all lowercase, snake.py. And now is where we're going to go and capitalize it. Class, capital S, snake, colon. When we press enter, it's automatically going to go and enter a new tab for us. We're going to need to go create that constructor, that thing to go and create this new snake. So we're going to go type in the keyword here, DEF for define, double underscore init, double underscore. That is the name of your function. Open bracket, and if VS Code is nice, it'll close brackets for you. And now, first parameter. What is the first parameter you got to put in any function for your inits here? Self, self, self. Yes. Thank you, guys. Everybody, type it with me. You got to put in self as that first one there. Okay, let's see. What else do we want to say this snake has? We don't have to stick with the same color, age, name thing. What are some things that this snake has that our snake has? We got a length. Okay, we'll set a length. We'll get a color again. You know, species. Okay, okay. It has a name, sure. You know, snake has dream. It has a profession as well. Existential dread. I'm going to go and add that in just for fun. Sure, why not? So I'm going to go and say self.name, self.length. Let's keep it in order just for convenience. Self.length equals length. Self.color equals color. Self.species equals, well, you know what? This is kind of cool. We can go and just default it. We don't have to go and use it right now. I'm going to just go and say Python. We're going to just go and secretly ignore this one here. Okay. I'm just going to go shorten down this list here because I know that it's going to be fun, but we'll be here for a while. So I do want to keep name, but dream, professions, and dread, we'll go and keep those out elsewhere. Yes, I agree. Snakes are complicated. Self.name, we're going to go and set it equal to the name that you can pass in. And if you want some defaults, you can go self.dream, greatest Python coder in the world. Everybody, every single snake's going to have the same dream when we start them off. Okay, so let's read this over real quick. This is a function. This just does function things. It can do whatever you want. So if I want, I can also go and type in print, my dream is, and then I can go self.dream to go and access that dream. I can do anything I want in here. You can put complex logic. You can draw trees lined up nicely. Anything you want is available here. But reviewing it one more time, we got the class snake. Everything about the snake blueprint fits in here. When we go and create the snake the first time, double underscore init, double underscore, also known as dunder. We're going to go and pass in self, first keyword there. And then we pass in all the parameters we want. We're going to set the length of the snake, set the color, set the species of that snake to be Python. And just to keep it organized, I'm going to cut that line, paste it, set the name. So it's always easy to read there. Why bother making the self variables instead of using the parameter inputs? That's a great question. We can technically go and skip that if we really wanted to. We can go and say, oops, print, my name is, and I can choose two ways to do this. I can go self.name, or I'm lazy, I can just simply duplicate this and I can go like that. But I'm going to definitely want to go and hang on to these parameters in the future. Excellent question, Jonah. We're going to see in session number 3 why it's so crucial to go and assign all these variables, even if it does look a little bit redundant right now. All right, I'm going to go and pop out this one here, Control/, just to go and keep a little bit organized. And we're going to go back to our main file here. I'm going to just go and take main, copy and rename it, copy it, rename it. I'm going to call this main snakes. Main snakes, okay? And down here inside my setup section, line number 23, mash the enter button a couple times. Oops, oh, I'm sorry, I almost forgot. We need to go and talk about importing. We need to go and bring this into our file. Again, from which file do we want it from? We want it from the snake file. Imports, what are we importing? We are going to import the snake class, capital letter S on that. Okay, perfect. So down here, we should be able to go snake1 is equal to a capital S snake, open bracket, and it'll tell you a list of things we want. How long is this snake going to be? 69, nice. And we're going to go and set the color, open the tuple, close that tuple off, and we're going to go and set 100 to 55, 100. We're going to set that name as Billy. I'm going to make a second snake just for fun. Snake 2 is equal to snake, and I'm going to go and say 1, 2, 3. I'm going to set the color to be, oops, I'm going to go and set that color to be a little bit yellowish, so 255, 2550. And I'm going to go and set that name to be Sammy. I think I might have used that name already, but who knows. Okay, anyways, I hope that you guys can see the example here. We can go and create snakes from that. And if we run that code, since I promised you that this is just a function that happens down here, oops, we got Pygame. I'm going to pop that off to the side where we don't see it. And my name is Billy the Snake. We go and take a look inside the snake file over here. Let's close that off just so a little bit easier to read. And we see it goes and sets up the length, color, name, and it says, my name is self.name, Billy. My dream is self.dream. You can run any code in here. I can go 2 + 2 = 4 if I want. I can go and set a world and stage the world in here. I can go and create like all the snake's friends and family down here. There's plenty you can do and plenty you will do in there. And we can see this code is repeated again for Sammy the snake. That's done down there. Okay, let's pop through the slides again. I think that we are basically blasting through this here because we basically did the exact same thing down here, creating our instance variable that's in a different file, and we put that in a different name here. And of course, one little detail you might have noticed, this self keyword, why didn't I type in self? It's because it is kind of automatically invisibly passed along. It kind of comes with objects and classes and objects. And come chat to me afterwards if you want a deep down explanation for what that self keyword actually is doing. There's some technical details. I'm not covering them right now. Okay, so you can also see here that my snake is Buttercup, and we can go and get it to do anything we want. It can print out SSSS. It can print out its dreams that it wants to be a little bit more than a lowly snake crawling on the ground. We can get our snake, we can go and change its name. We can go and treat it like any other object once we get out of here. Which brings us straight up into quick question number 2. What's going to be printed out when we run this thing? All right, 30 more seconds, get that submission in. Okay, wrapping up in a few seconds here, get those last answers in and we will be closing them off. All right, closing off the polling here. Okay, cool. So we know, or I want to go and hear from you guys. We didn't get a perfect consensus on what the answer is going to be here. So what is going to be happening here? What did some people say? Anyone want to share their answers? Okay, we can print George once. You got anyone else who wants to share what they got? All right, we got people thinking print George once. Make a person object. That person object will do all that stuff down there. We didn't pass anything in, so I don't know if it's an error because that's undefined. Creates a person object, set the name to George, print George, print George. Okay, sounds like, yeah, it sounds like we got a bit of a consensus down here. So some of us thought, wow, there might be an error going on. And this is kind of one of those weird quirks down here. That self keyword's a bit magical. That's why we have this self.name thing. It's an object that sort of exists behind the scenes and creates itself. It's one of those weird technical details, but I'm going to go and highlight back on our slides here. That you never pass in the self keyword. Self automatically goes to it already. Shout out to Dad, love it. So we already see that self is already handled in here. When you see snake or any function that belongs in snake, yes, we'll learn what that means later, it automatically passes in that self keyword. So that is why, even if you don't have that self keyword here, right down here, or any parameter at all, this still works a-okay. We can even go and prove that real quick. I'm going to go create a new file, and I'll just put this all in the same one. Person.py. I could do everything right here. Class person, and then I can go def dunder init self keyword, and then I can go and self.name equals George, print self.name, and you can actually keep this all in the same file, skipping that whole import thing there. Why does person equals person make the function run? Excellent question. That is just kind of how the nature of this works here. When we say P or person or whatever you want to call it equals person, you open the bracket here and it says that you need no parameters at all. And I can prove that it runs and it should work a-okay. We got George popping out down here. Excellent. So those of you who got George, congrats. Why does this make it run? Well, it says we need to go to the double underscore initialize function. Whenever we create a class, how do we create it? We need to go create it in the initializer here. And then it will go and pop itself up. It makes a piece of magic happen, or that self becomes an object that's invisible, and it goes and creates it for you. And at the end, it's a little bit subtle and really doesn't ever do this practically, or you should never worry about this. It secretly kind of does this, return self, so that you have a person to play with. Doesn't it set the variable to the object person? I believe that's along the right lines there. We can have a talk about that more. Jonah, if you still are confused, go talk to your mentor about that. I'm not trying to brush you off. We're just a little short on time. All right. So I want to go and touch on another topic here, and it's back to objects, but still integrative classes, that objects can have other objects inside it. I hope that this is actually a lot more intuitive than it looks. The reason for this is that objects are just variables, right? Objects are just really big boxes that can go and hold stuff. And what can you put inside a box? You can put small boxes, or you can put other big boxes inside there. And you can put this as many boxes as you want. So if we have a snake that has a pet, we can go and put that pet inside there. If you have a big box, you can put another little box in there. Or could you have a cat in a box? Absolutely, I love it. Objection, objectception, yes, I love it, thank you. And if you look at the Mars rover, that's going to be coming down super soon. We got that Mars mission spacecraft that's flying in. Inside it is an object. That Mars rover lander. Coming down inside there is a sky crane. And inside that is another thing. That is going to be the rover itself. An object inside an object inside an object. Why am I mentioning this? Because it's so useful, because we can make really, really big abstract concepts. We're not just limited to our little pet shop anymore. We can go and build an entire city using this concept here, which I want to go and quickly show off the syntax here. Let's say, for example, I want a rectangle for some reason. I don't know why, maybe it becomes useful in the future, hint, hints. So we got some objects here. There's no new syntax here. They're just variables, right? So I'm going to just simply read off the slides here rather than typing it out. We got class snake. This is nothing new. Def init self, nothing new in there. So we're going to set it to buttercup. We're going to go and print out SSS. But let's say this snake has its favorite rectangle as a property. That is just simply saying, hey, my big snake box, please make a box inside called rectangle. Well, rectangle is actually kind of complicated. It's a big box itself. Inside there, we're going to go and create a pygame.rectangle, and you can go and just plug in your rectangles and anything you want. We're not just plugging in X, Y coordinates anymore. So you know that tree wouldn't have been much easier if we had one rectangle for the trunk, one rectangle for the leaves on top. Well, I think that would have been really nice. Anyway, if you want to go and access it, this link's getting in my way. All right, down here underneath, we see my snake equals snake. Down in that bottom box, you'll say print snake's X coordinates. That X coordinate no longer is from the snake directly. It's going to be inside the rectangle. So we're going to go with my snake dot rect, get in that box here, dot, go inside the box again, grab the X coordinate from there. So this might be a little bit scary for some of you guys. Don't worry, just naturally comes with a little bit of practice here. I'm going to blast through this quickly because we're not going to worry about this too much. Imports, we saw this out all over the place at the top of our files here, and we have to use it all the time. So, oops. So when I talk about main lots of recs, we see import system, import operating system, import pygame. And then down here, from the file, import something specific, the tree class. If you don't use the from line, you're just going to import everything under the sun, but you're going to have to do pygame.rect, for example, or pygame.draw. I could technically actually do from pygame import rect. If you guys want to go and get a little shorthand, that makes it convenient. So you can go my rect equals rect, and you can skip that pygame dot at the front. That's up to you for personal preference if you want to do it. For now, we're going to stick with keeping pygame in the front, just so it's a little bit more obvious for you guys. Okay, oops, let me go and pop back to slides here. It's really just a good way of keeping it organized. You see that code gets massive. We don't want to put it all in a single file. And yeah, as I just pointed out here, from pygame, import rect. From snake, import snake class. From some module, those files are called modules, import some class. So we look for a file called another module.py and import that. Excellent. So as you guys have probably noticed, I've been saying it a lot of times already. If you're going to have a class, it's going to be called Pascal case. You capitalize the first letter here. And if it's a multi-word letter, so some class, no space, you put a second capitalized letter there. That's just a convention. If you break it, no harm done, but please stick with it. It makes my life a lot easier. All right. So I think that we are going to blast through this from import example, example.print text, or import pygame, pygame.drawRect. These should be something similar or familiar you guys can see. Put it at the top of the file, make your life easy. There's some built-in ones already. So I mentioned like import operating systems from the math library, import sine, cosine, absolute. Those are really useful actually. And you guys saw import pygame. We've been using that a lot lately. So we've seen the from. I'm not going to touch that again. I'm going to just mention that there's the as statement as well. We're not going to use it too much, but sometimes you might see it. If you don't want to type out pygame every single time, because that's just kind of annoying, you could go and actually abbreviate it. So let's go and take a look here. That's going to be import pygame as pg. And then now you can go and say, instead of pygame.init, I can just go pg.init. But again, I'm not going to go and stick with that. That comes really useful sometimes, but I'm not going to go and dive into that today. Oops, again, moving to the wrong slide. Okay, we're going to take 30 minutes here. Oops, a little short on time. We're going to go and take 25 minutes here. And we're going to go and just draw some rectangles on the screen. These are going to be the platformers. These are going to be the foundation to our games. So let's go and have some fun with them. If you want, make them move across the screen, slide across. I think that'd be super cool. And last part, we're building this game together, guys. So I'm going to go and ask you guys, go and click on this Google form here, share your results, and take a look. Don't be shy. Your name is 100% optional, so you can completely skip that. But if you guys want to help out building the game here so that we all have something really cool, jump in here, upload something, and we're going to go and create something really awesome. All right? Awesome. Let's get cracking. game. So I'm really hoping that you guys can help me out and submit a couple entries here. We're going to go and take a look at these entries, and we're going to go build together one common thing that we can work on together. So I'm still waiting for a couple submissions here. Opening it up so far, I don't see any submissions yet in my folder. Have we had anyone submit their code yet? I'd like everyone here to submit. Everybody, no matter how many lines of code you wrote, I want you guys to submit. And it's anonymous. So if you're shy and you're embarrassed about it, just hide your name. I won't know. I set this up, so I cannot tell what your name is. Okay, I'm starting to see a couple submissions coming in here. Still going to wait for a couple more. I'm seeing them starting to enter slowly, but thank you guys. Thank you very much for submitting. This is really a big, brave step for you guys. I know, but don't you worry about it. I'm going to wipe off the names from everything. You guys are not going to have to be worried about that at all. Okay, I'm going to be picking these at random unless if somebody's really proud of what they want to show off here. And I can start with anybody who does want to go and show up and want to be first with that. All right. Mitchell is definitely super interested. He wants to go and take a look at that. I'm going to wait. I'm seeing 9 responses. Keep on going. I know there's a lot more than 9 people in this room today. It's collecting email addresses. Interesting. Don't you worry. I'm looking it over right now. I promise you, I'm not reading the emails right now. Okay. If you guys are already here, we're already snooping on some stuff. I hope you guys trust me a little bit more than that. That's an interesting comment. Excellent. Thank you guys. Let's start compiling these answers together. I'm going to start downloading a couple of these. And I'm unable to go and access my own folder. Go figure the irony. That's okay. I set this up so I can go and read this. All right, let's go and take a look. All right, here, I'm just going to start downloading some files here. And why do I not have access to my own system? That's interesting. All right. Well, that's a technical glitch I really hoped I could have worked out before today's session, which is kind of ironic. Okay, well, keepers. I don't understand why I don't have access. That's going to be a little bit annoying. So I'm going to pull over to the next best alternative. I'm just going to go and make a Google, or I'm just going to go and make a file that everyone can go and manually copy their code. I'm sorry for the technical difficulties. I did not expect that this would go wrong here. This is what happens when you don't test links. And there's an entire class on testing programs so that these links don't happen. I'm going to go and create a new Google file, or Google Docs folder. Oops. Or Google Docs, create that. And I'm going to share it with the world here. Once again, go ahead and just simply pop down whatever code you got, and I'll manually copy paste it. And change it with anyone to the link can go to edit this link. Goodness, what a technical mishap. What a maroon. Let's try that one more time, shall we? Everyone, try one more time. Let's just go onto this Google Docs right here. Please copy paste your code there. I am really sorry that I'm unable to go and view your code. I somehow created the form and don't have permission to my own form. Strange. Thank you, Teresa. Sorry, I'm terrible with names too. All right, please copy paste your code. Just take the code, Control C, Control V, or Command C, Command V. Excellent. I'm starting to see some entries here. Excellent. I'm going to go and start grabbing this first one here. Woohoo. Okay. Class platforms. Platforms is equal to this big thing. All right. Class platform. Let me go and take a look at an example that we see here. I'm going to go and take this one. This looks like a pretty solid example for what we're going to go and get started with. What I'm going to go and do, we normally have our folders for every single day. I'm going to go and flip over instead to jump into my documents as usual, a little bit hectic when you're doing these things on the fly, and jump into my folders so you guys all get to stare at my folder system. Maybe that's not so smart. I'm going to go and jump in. Right then, where is it? Where is it? Ignite sessions. Here we are, finally back at it. Could you all do me a favor? Session 012, let's add a new folder in there. Let's call it the game. This game here is where we're going to go and make the magic happen. I'm going to go and open with code here. And I'm going to go and create this platform.py inspired by the work that I've seen some people do right here. Class platform, excellent. It is looking good here. And of course, I need that main file, main, copy and rename. Grab that, drop that into here, and rename that to main. Okay, and back on VS Code, we should be able to go and see that. Excellent. This is going to be the main, and we're going to go from platform, import platform. Excellent. I want to go and check out some of these other submissions that people have been popping in here. So from platform, import platform, I got this beautiful setup section here. I got a list of rectangles popping in. I'm going to go and start mix and matching a little bit of these answers here. We're all going to go sit down together, work through what we can see here. So I'm just grabbing some random entries here, but you guys are able to scroll around. You guys can go and check out everyone's work here, and we can all start comparing. And hopefully you all trust me that this is all anonymous as well. So back on to it. So we're going to take a look at the platform here. We got class platform. What do we see? We see that it's def init, so you go and create it. Excellent. I'm seeing that you pass in these x coordinate, y coordinates, width, height. You can also pass in the color. Just for my personal convention, when I program, I use American spelling. I know that's going to annoy a few of those people out there. I'm going to go stick with my American spelling here. And so I think that this is a fantastic start. We all got these variables floating around, but I'm going to go and take a look at how we go and draw these rectangles here. So I'm going to go and scroll around, find somebody who has written up a draw section for me, taking in the sites here, taking in the scenery. Cool. To-do draw platforms. That's A-okay. That is exactly why you write to-dos onto your code here. So when we paste this in, we will see, oops, little formatting issues here, and I posted it in the wrong spot. So let's go and pop it down here in our draw section. I'm not too concerned about making sure that all the it's all moving around. I want to make sure that it actually is draw. For platform, and ooh, someone's getting pretty sophisticated. Game state stop platform. Let's go and simplify that down. We're just going to get a list of simple platforms. We got red. I respect it. We got a good color here. And they said, and for those of you who did not know, this was a to-do comment. Draw platforms. So it's just an incomplete piece of work here. Let's go and quickly wrap this up. I apologize. We are running a little bit over time just because of these technical hiccups. What I wanted to go and highlight is that rather than just simply posting in the coordinates directly here, what if we clean this all up? I'm going to go and use a Pygame rectangle. Imports, Pygame. And I'm going to stick with this. X, Y, width, height, color. I'm loving it. I'm going to go and replace this with self.rect equals Pygame.rect. And I'm going to go and put in that X, Y, width, height. Excellent. And because of that, I can take all this code here and I can go and comment it out. It's not going to be necessary right now. Whoops, and just to make sure that the formatting does not complain, I'm going to go and make sure that that is all good. I'm going to just go press tab, make sure it lines up properly. What's the advantages of using rect? Does anyone want to give me an answer in chat why we're going to go and use rect rather than just typing out self X, Y, width, and height?
Saves your fingers from typing too much.
That's a good one. I like it. I like it. One object instead of 4 variables. One packaged thing to keep it organized. Our platforms might be more than simple rectangles on the screen. If we want to make it scale up, it works really well. And I'm going to go over here. I saw some people working on a solution here. We got a rect list. I'm going to go and swap this out real quick with platform list. Platforms equals a square bracket. And I'm going to go def add platform. I'm just going to pass in X, Y, width, height. And I'm just going to get cheeky with it. I'm going to also, oh, never mind. Since I'm short on time, I'm not going to try cheeky randomized colors here. Instead of doing individual rectangles living apart from my platform, I'm going to make my platforms have the rectangles. When the bloke gets cheeky, we're going to go for P equals platform. What are the parameters we're passing in? Those are going to be the X, the Y, the width, the height, and the color as well. So it's just a matter of copy pasting here. And we're going to go platforms dot append P. Excellent. So we're going to go, and once we get that, we're going to go and populate a couple platforms. I see somebody has done me an awfully good favor here. They got some platforms already rolling, so I'm going to go and pop them down to here. And I can just simply go and reverse some of these numbers. That's my X, that's my Y, that's my width, that's my height. And I believe that this last number 10 here, I apologize if I don't see this last number here, given the amount of chaos here. I hope you guys can forgive me for being a little less than organized. I'm going to go add underscore platform. What this does, I'm going to call this function, which in turn creates a platform with those and plugs it straight into our list. And get rid of this extra variable here, just as well, nice and tidy. And I'm going to go add platform down here as well. I'm not too concerned about the specific platform numbers today. Those can always be tweaked out with little minor details at the end here. We got add platform, we got add platform. So now we got platforms, we got 2 of them here. And down here, for platform in platforms, we're going to use Pygame. We're going to draw a rectangle here. What rectangle are we going to draw? We're going to go and draw the platform dot color. We're going to go grab its color here. And now we're going to say, where do we put it? What rectangle do we put it in? Platform dot rect. Excellent. Let's go and see if we can get rid of this to-do comment. Having my faith in you guys here. And we got a little bit something wrong. And it takes 6 positional arguments, 7 were given. 6 positional arguments, 7 were given. We'll take a look over that real quick here. That's X, Y, width, height, and oops, that's right, we got some extra code here. I'm gonna go and pop out this one here. I'm gonna stick with platforms equals this square bracket def add platform. Let's try that one more time. And there we go, we got some rectangles on the screen. If you guys were interested in how do you go and make them move, there are more than one answer to this. I'm going to use one that perhaps is not what we thought was conventional. I'm going to go and set up a timer equals 0 here. And in my update section, timer plus equals 1. That's the first piece of logic. Oops, never mind. I'm putting that down at the bottom. I'm going to go for platform in platforms. Every single platform, I'm going to change the X coordinates. We're going to go and finish this off very quickly. I apologize for being overtime. We're going to go platform dot rect dot X minus equals, or minus equals 1. There we go. And we should go and get the really cool effect of making the rectangles move. I realize timer is actually irrelevant. We'll go and take it out of the conversation. We're running over time very badly. Let's wrap it up here. If you have questions, you can go and check out with your mentors on Discord. If you got to pop out, now's the time. But before you go, last little question for you guys over here. Can you do a quick poll and just tell us how we did today? Awesome. Thanks, guys. Once you finish that poll, you are free to head out, but please get that done before you leave.
Bye, everyone.
All right, see you all next week. Take care, everyone.